Hey guys, Mr. Regan. Today we're going to look at similar figures and scale drawings. So if you look here, you see a bunch of examples of similar figures. The two blue pentagons are similar. These two green quadrilaterals are similar. These two green rectangles are similar. And then these two red triangles are also similar. Alright, three things that you need to know about similar figures. One, they have the same shape, but not necessarily the same size. So that means they're kind of like if you took a drawing and then went to a copy machine and enlarged it, and then you would get the same picture. It would just be a bigger version, or you could shrink it, it would be a smaller version. So when two things are really the same shape, but one might be bigger than the other, but not necessarily, because when two things are congruent, we also say they're similar. Alright, the second thing, the corresponding angles have the same measure. So that means all the angles that correspond to each other, meaning they're in the same place. So like, we'll talk about this later, but this angle B and this angle E are in the same position. They would be corresponding. They would have the same measure. And then lastly, 3, the corresponding sides are in proportion and each have the same ratio and the same scale factor. So we'll talk about all three of these one at a time here. All right, number 1. They have the same shape but not necessarily the same size. So if you look at these two triangles, they are the same shaped triangle. And be careful, when I say same shape, I can't have a triangle like that and then a triangle like that and say they're similar. They might both be triangles, but they're not the same shaped triangle. So they would not be similar. But these are the same exact shaped triangle. One's just a bigger version of the other. All right, so that's the first thing. And keep in mind, they could be congruent to each other. They could be the same. We would also consider that similar. All right, number 2, the corresponding angles have the same measure. So if I look on the big triangle, I have 3 angles: angle A, angle B, angle C. On the little triangle, angle D, angle E, angle F. And then there's these markings on there. The markings represent a comparison to show you like which angles are actually the same measure. So let's start out by looking at this angle C and angle E. They're corresponding because they're both in the same part of the triangle. And if you look, they both have a one little line mark there. So that means they're both the same angle measure. And then same thing over here with angle A and angle D. They're in the same position, so they're corresponding. They both have the 2 little marks, so that means they're congruent. They're the same measure. And then lastly, angle B and angle E. They're also in the same parts, and if you look, they have the 3 lines there to show that they're the same measure. All right, so corresponding angles have the same measure. They're congruent. If I told you that angle C was 30 degrees, then angle F would be 30 degrees also. All right, number 3. The corresponding sides are in proportion, and each have the same ratio and the same scale factor. All right, that sounds a little wordy, but that's not a big deal. So all I'm talking about here is in proportion. So let's make up some proportions here, and you'll see. So first off, I have to find the corresponding side. So this side right here, segment AB, well, that corresponds to this segment DE. Okay, they're both in the same position. So I could do 40 on the big triangle over 4 on the little triangle. I come over here, 50 and 5 are corresponding. 50 on the big, 5 on the little. And then 60 and 6 are corresponding. 60 on the big, 6 on the little. And there's equal signs in between all them, because if I simplified each of those, I get 10. So since they all equal the same thing, then we know that they're all in proportion, and that's what we're looking for. If one of those did not equal one of the others, then we would not be able to say that these triangles are similar. Okay, so they have to follow all 3. Same shape, corresponding angles have the same measure, and the corresponding side lengths are in proportion and have these same ratios. So like that ratio, and that ratio. And they all equal this 10, which is our scale factor. Alright, are these polygons similar? If so, write a mathematical similarity statement. Alright, so I'm going to go through my checklist. Are they the same shape? Yep. I have like a small version of this quadrilateral or trapezoid, and then I have a big version, and they appear to be the same shape. Second, are the corresponding angles congruent? Well, it looks like D and T are corresponding. They both have 1 mark. C and S are corresponding. They both have 1 mark. Let's see. A and U are corresponding. They have the 2. And B and R are corresponding. They have 2. All right, so check for number 2 also. The corresponding angles are congruent. They have the same measure. And then 3 are the corresponding side lengths in proportion. All right, well, let's check. Let's use yellow. Alright, so 6 and 3 correspond. So there's going to be our first one. And I could write it the other way around. I could put small on top and big on the bottom. I just happen to do it this way. Now I'll just stay consistent though. 4 corresponds with 2. 6 corresponds with 3. And 7 corresponds with 3.5. And if I simplified them all, or if I divide it numerator by denominator, I would get 2. So they all are equal. They're all in proportion. The ratios are all equal. And our scale factor would be 2. So the answer is yes, they are similar. And our statement. Alright, so I have to name these. If I was naming triangles, I put a little triangle symbol. But if it's not a triangle, you don't need a symbol necessarily. Let's do this down here. So I'm going to say quadrilateral A, B, C, D. I'm just going right around. Is similar to. All right, now here I have to be careful. I have to make sure that the corresponding parts match. So since A was the first letter, I got to come over here into the smaller quadrilateral and find the letter that corresponds to A, and it's this U, angle U. And then B is the second letter. See right here? So I've got to find over here what corresponds with B, and that's the R. Then C is the next letter, and that corresponds with this S right here. And then lastly, the letter D corresponds with T. So then this would be my statement. It's called a mathematical statement of similarity. Alright, so a similarity statement, a mathematical statement, and that squiggly is our similar symbol. Okay. Now this isn't the only answer, because I could have written it different ways. I could have said BADC, and then that's going to change the order of the letters the way I'll write for the second quadrilateral. But as long as the first letter matches up, corresponds to each, the second corresponds, the third corresponds, and the last one corresponds, then you're okay. Alright, we're going to solve for some missing angles. Now this is actually really easy because there's not a whole lot of math. It's just a matter of matching angles. So it tells us right here, gives us this statement. ABCD is similar to WXYZ. So now I know what angles correspond to each other, but I can also tell because I see that angle A has the one little marking, and so does W. So they're the first letters, so they go together. So I can see it in the statement, and I can see it in the picture. All right, so I'm trying to find the measure of angle W. Well, W corresponds to A, and A is 80, so W is also 80 degrees. All right, next X. X corresponds to B, and I can see that here in the statement. They're both the second letters, or I can see that right here. They go together. So B is 75 degrees, X is 75 degrees. See, no real math. I'm not doing any calculations here. Y corresponds with C, and C was 120 degrees. And then Z corresponds with D, and D was 85 degrees. All right, so finding missing angles is pretty easy. It's the side lengths that's the hard one. All right, so now we have two similar figures. It tells us right here in our statement, and we're going to find M. So there's our M. All right, so I'm going to make a proportion. Since the side lengths all have to be in proportion, I'll use a proportion. So I know that M on this bigger quadrilateral corresponds with 12 on the little one. So I'm going to do M over 12. Now I got to find a number on the big quadrilateral and then a corresponding number on the little one. So if I try 24, I look over here, that corresponding side doesn't have a number there, so that's not going to work. So now I'm going to try 15. Oh, and yep, there's a 10 right there. So I'm going to do 15 over 10. And that's important that I did 15 over 10 because I did M, the bigger quadrilateral on top, and then 12 is on the smaller quadrilateral on the bottom, so I had to do the same thing here. 15 had to be the big quadrilateral, and then 10 would be the small quadrilateral. Ooh, that's as big. Alright, so now I'm going to solve my proportion. I'll do cross products for this. 10m, 15 times 12 I believe is 180. Divide each side by 10. And m equals 18. Let's not forget our units of measure. Oh, no units of measure, so I don't have to worry about it. Let's make this nicer. This was 18. And I'll just say m equals 18. But if it would have been inches or meters or something, I would have put that in there. Alright, last one, or last two actually. We're going to solve for x. So here's our x right here. So once again, I need a proportion. So x, and x corresponds with 10. How do I know that? Well, I can look at the picture and see that they go together, but I could also say that x is DE, this segment, and DE are the first two letters, so it must correspond with AB. The first letter is over here, and there's AB, and that's where 10 is. So a couple ways to figure that out. Right now, I did x on top, and that's on the big triangle, so I could do 12 on top, and that corresponds with 6 on the little one. Do some cross products. 6x equals 120. Divide by 6 on both sides. X equals 20. And once again, no units, so x equals 20. I also like to look at my answers here and see if it makes sense. I mean, does 20 make sense? Well, yeah, it does, because look, 6 times 2 equals 12. 10 times 2 equals 20. You know, if I would have got a small answer here like 5, like that wouldn't have made sense. How could it be a smaller number on that bigger triangle? And then notice up here in my similarity statement, I said earlier, for triangles we use this little triangle symbol. For anything bigger than that, don't worry about a symbol. Right now we have two quadrilaterals, and here it might get a little tricky because they're turned. They're not facing the same direction. So if you're not sure what corresponds, you have to look up here at this statement. So I'm looking for x, and what does x correspond with? Well, x is segment DC, so that's right here. So they're the last two letters, so the last two letters here are GH, so it corresponds with right here, which is 9. So x over 9. Now I need those measurements on both. So I only have one number over here, I have a 4, so that's going to go on top, just like x went on top, because it's the smaller object. And then 4, does 4 go with the 8 or does 4 go with the 6? So 4 is AD, that's the first letter and last letter. So EH are the first and last, EH is right here, so it's the 6. I'll do my cross products. 6x equals 36. Divide by 6, and x equals 6. And this one does have units, centimeters. Oh, no, meters, I'm sorry. Oh, that was terrible. 6 meters. Oh, I see what I did. I wrote centimeters for some of them. I wrote meters for others. Let's just say they're all meters. Get rid of that, and we're good to go. All right, there you go, guys. That's what we're doing for similar figures. We are setting up proportions to solve for missing side lengths because we know that the sides are all in proportion. They have the same ratios. For angles, we know that corresponding angles are congruent, so no calculations there. And then we know that similar figures all have the same shape as well. All right, good luck.